Welcome to The Explainer. Today, we're talking about the moon, our closest partner in space. You know, it does a lot more for us than just light up the night sky. We're going to explore just how much it truly shapes our world.
All right, let's just jump right in with a little thought experiment. I want you to imagine, just for a second, what if one night you looked up and the moon was just gone? No familiar silver glow, nothing. It sounds like sci-fi, right? But thinking about it really shows us just how vital our lunar buddy actually is. Yeah, the consequences, they wouldn't be subtle at all. I mean, we're talking catastrophic. If the moon vanished, our planet would be fundamentally altered, and we'd feel the effects pretty much instantly. Okay, so the very first thing you'd notice, the oceans. The moon's gravity is basically the puppet master for our tides. Without that pull, that familiar ebb and flow of the sea, it would just collapse. And that's just the start. You see, that huge change in the tides would create this massive ripple effect. Those ocean currents, which are kind of like giant rivers in the sea, they move warm water all around the planet. They're a huge part of what regulates our climate. And without the tides driving them, the whole system gets thrown into total chaos. And from there, it's like a devastating domino effect straight through the natural world. Think about it. All those coastal ecosystems that depend on the tides, they'd be wiped out. And so many animals, predators that hunt by moonlight, creatures whose entire life cycle is synced up with the lunar phases, we're talking about a mass extinction event. Just how big of a deal is this? Well, the sun does have some gravitational pull on us, but it's way, way weaker than the moon's when it comes to tides. So if you take the moon out of the equation, our ocean tides would shrink down to just a third of the size they are right now, a huge difference. So you might be wondering, why would losing the moon cause so much chaos? It's clearly about way more than just the tides. The real secret here is the moon's role as Earth's gravitational anchor. It's basically our planet's stabilizer. And it all boils down to this one thing called axial tilt. You know how Earth is tilted on its axis? That little lean is the entire reason we have seasons. And guess what? The moon's gravity is what keeps that tilt nice and steady. And when I say steady, I mean it. The difference is just staggering. With our moon, our tilt is locked in at a nice, stable 23.5 degrees. But without it, Earth would wobble like a spinning top that's about to fall over. The tilt could swing wildly, anywhere from 0 degrees to 85. Can you even imagine? It would create these insane climate extremes. Say goodbye to regular seasons. Okay, so we've established why the moon is absolutely essential for life as we know it. So the next big question has to be, where did we even get it? Where did this incredible partner of ours come from? Well, the leading theory is pretty intense. It's not a gentle story. Let's just say that. It's a dramatic tale of a cosmic smash-up that went down about 4.5 billion years ago, way back when the Earth was just a baby. So here's how scientists think it all happened, kind of in 3 main steps. First, this other planet, about the size of Mars, they call it Theia, it just slammed right into the young molten Earth. Bam. Second, that collision was so catastrophic, it blasted a huge cloud of vaporized rock and junk into orbit around Earth. And finally, step 3, all that debris started clumping together, thanks to gravity, and eventually formed the moon we see in our sky today. Wild, right? So this incredibly violent birth created a world that feels both familiar to us, but is also totally alien. It's so much more than just a big rock in the sky. It's a complex, fascinating world all on its own. All right, let's take a look at a quick comparison here. What really jumps out at me is this. The moon's diameter is about 1/4 of Earth's, which is pretty big, but its surface gravity is only about 1/6 as strong as ours. And that right there is why you see those old videos of the Apollo astronauts bouncing around and leaping so high. You know, the moon's surface is like a history book, telling the story of the last 4.5 billion years. You've got those dark, smooth patches. Those are ancient volcanic plains that people used to think were seas, so they called them maria. Then you've got the brighter, older areas called the highlands, which are just covered in craters. And here's the really exciting part, especially for the future. We've confirmed there's water ice hiding in craters at the poles that never, ever see sunlight. You know, for all of human history, we've had this deep connection with the moon. I mean, from ancient gods and harvest calendars, all the way to the space race and modern science. Our relationship with it is always evolving. And that journey, it's definitely not over. Our hands-on exploration really kicked off back in 1959 with the Soviet Luna 1 probe. Then, of course, the absolute peak was 1969, Apollo 11, humanity's first steps on another world. Incredible. And now, we're diving into a whole new era. The Artemis program is aiming to get humans back on the lunar surface within this decade. It's happening again.
But here's a funny thing. Even as we're planning to go back, our relationship is literally changing in this slow cosmic dance. Get this. Every single year, the moon drifts away from the Earth by about 1.5 inches.
And you know what's causing that? It's those same tidal forces we talked about earlier. The friction from the tides is actually slowing down Earth's rotation, just a tiny, tiny bit. And all that energy has to go somewhere, right? It gets transferred to the moon, pushing it into a higher orbit, farther away. So that leaves us with a final big question to chew on. As our closest partner slowly backs away from us, what does our future together actually look like? What does it mean for Earth and for our own future out there among the stars?